All right, let's begin by talking a little bit about our friend slope. So this is an essential part of lines and graphing lines, and so there are some basic setups here. This line here has what we call a positive slope. A way to think about that is it rises as it goes to the right. So as we move to the right, it's on its way up. That's a positive slope. This one is a negative slope because it falls to the right. So as we move in a rightward direction, we are on our way down. So these are positive and negative slopes. These are kind of unique. If you think about a slope of a hill that looks like this has zero slope, and that's what this is. This slope value, or m, equals 0. This is a horizontal line, and it will always have a slope of 0. Now, the equations of these are kind of weird, actually, and this is something to remind you. Let's say this goes through the y, the 3 value for y, and actually that becomes the equation. This would just be y equals 3. A way to remember that is that it crosses the y-axis at 3, and so that's y equals 3 is that guy right there. A graph that is a vertical, so this is a vertical graph, its slope is what we call undefined. Part of what's happening there is that you are dividing by 0 in a rise over run environment because the run is 0. And so it is an undefined slope. These are vertical lines, and they are described as x equals. So let's say this was at -2 here. This would be x equals -2. Just remember that these are a little bit unique in their style. So let's talk more about the calculation of slope. I mentioned the idea of a rise over a run. The way we would work out a slope is we would take 2 points that are on the line itself, and often we draw this little triangle that's here. And a slope is a relationship, a change in the rise and the run of the values. So sometimes we say rise over run, or delta y over delta x. Now delta is another mathematical symbol for the change in y and the change in x. And ultimately that formula becomes, if we put in some points here, this would be x1 and y1. This would be x2 and y2. This point right here, we'll grab this one, it would be x2 and it would be y1. Now, if you were trying to calculate the change in the rise from here to here, we would actually look at these two values, which would be the difference in the y values. That's what we mean by this. And if we were calculating x, we would take a look at the x values that are changing here, and this becomes our formula for slope. Let's take a look at a couple examples of how to calculate slope given some different numbers. But this is the mechanism. It's the change in the height over the change in the run, right? Rise over run each time. So let's try a problem. Let's just pick 2 points. Put some negatives in there because that's always tricky. All right. Now, students often ask, well, who's the y1 and the y2 and the y? It does not matter in the case of a slope. So let's just make this our x2, y2, and this will be our x1, y1. And so it would go as follows. 5 subtract 4, and 3 subtract a -1. This becomes 1/4. This would be our slope. So when we calculate slope, let's show you that it comes out to be the same. So let's do it the other way. Had we done it 4 minus 5, negative 1 subtract 3. I get negative 1 over negative 4, which equals 1/4, and we get the same value. So slope is a fairly easy thing to calculate. You got to keep track of your negatives, but that's about the only thing that you got to worry about there. Let's take a look now at distance. So the distance formula is a bit of a beast, and you're aware of this. It looks like this. Now, there are lots of places where you can go wrong in that formula. One, just remembering it, but two, the negatives and the x1s and the y and all that stuff. I want to just show you that this is actually the Pythagorean theorem. And I'm going to show you my shortcut. I hope you like it. But I don't actually use this formula. I use the Pythagorean theorem. But let me show you how it's the same. So if I had a line and I wanted the distance, actually a segment, right? I want the distance between here and here. I'm going to show you how the Pythagorean theorem actually is what we're going to use to solve this. So here's our A, here's our B, here's our C, let's say. Now, how would you calculate how big A is if it was in a coordinate situation? Well, that would be the change in the x values. So A really is the difference in your x values. Well, how would you find out what B is? Well, it would be the change in your y values. Do you see the formula starting to appear? Do you see how they're kind of similar? And if I take the square root of both sides, I get our beautiful formula. So there is the distance formula, and basically it is generated by a squared plus b squared equals c squared. So I'm about to show you how I do it in my mind, and I'm going to not use this officially, but watch what happens. Because I find that formula is just got too much going on for students. So the way I think it works best is let's pick a point. And another point. All right, now here is how I do it. I think about the Pythagorean theorem, and I think of the A guy being the distance between the two of them. I don't worry about positive or negative. How far is it from negative 4 to 6? Well, that's 10. How far is it from 5 to 4? That's 1. And then this becomes what I solve, quote unquote, the distance formula. So this would be 100 plus 1 equals c squared. This would be the square root of 101, whatever that value is, just slightly bigger than 10. Wow, do you feel that was quite simple? Let's do another one quickly. Let's pick negative 4, negative 3, and let's pick 0 and 5. So if I was doing this one, again, the way I think about this is the Pythagorean theorem is really the distance formula. This is the distance between my x values. From negative 4 to 0 is 4. From negative 3 to 5 is 8. And this is what I will solve. 16 plus 64 equals c squared. This is 70, 80 equals c squared, the square root of 80. Just shy of 9 will be that as a decimal value. And I can simplify that and make that a little bit an easier guy. Let's do that. Let's practice that. That would be 16, right? 16 times 5, I believe. And so our final answer would be 4 root 5 would be our answer to that particular problem. That's our distance formula. Let's look at the midpoint formula as one last thing. The midpoint formula is kind of a nice little formula too. The way it works is we want to know the middle of 2 points. And again, we have an x1, y1, an x2, y2. And we want to know where's the exact middle. Well, if I was to give you two numbers and asked you for the middle number, you would average them. You would add them together and divide by 2. This is the same technique. Think about it this way, is that what we're going to do is cut this in half. That'll give us that. Cut this in half, and we will get exactly the middle. That formula looks like this: x1, x2, y1, y2. This is our midpoint. So, I don't know, let's pick 2 points, A at -4, 5, B at 3, 8. The midpoint would be to add -4 and 3, and +5 and 8. And then we are finding the average of these. And we are finding the average of this. And this is how that would be the exact middle point. You might change that to 6.5 or 0.5, whatever you wanted. But this is really all there is to the midpoint as well. So that was quick, but that's slope, distance, and midpoint and how to use them. Good luck with it.